Hello and welcome to my home tuition's YouTube channel. In this video, I'm going to discuss writing quadratic function in the vertex form by completing the square. I will also discuss determining the maximum or minimum point of a quadratic function from the vertex form and then using the Casio fx-570EX Classwiz calculator to verify our answer. This is a video sponsored by Casio Malaysia. A quadratic function in one variable is a function with one variable where the variable's maximum power is 2. This is a general form of a quadratic function. We can see that the highest power of x is 2. The shape of the graph of a quadratic function depends on the positive negative sign of the coefficients a. If a is positive, the graph looks like an N shape. And if the a is negative, the graph will look like a U shape. If the graph is an N shape, there is a maximum point on the graph. And if the graph is U shape, there is a minimum point on the graph. Finding the coordinate of the maximum or minimum point. There are many ways to find the maximum or minimum point of a quadratic function. First, we can use the axis of symmetry to help us to locate the coordinate of the maximum or minimum point. This is under the SPM Modern Mathematics syllabus. We can also use differentiation to find the maximum or minimum point of a quadratic function. Differentiation is under the Additional Mathematics syllabus in SPM. We will discuss this in the next video. Other than that, we can also use the quadratic functions in the vertex form to find the maximum or minimum point. This is the vertex forms of quadratic functions. In this video, we will discuss writing a quadratic expressions in the vertex form and then use it to find the maximum minimum point of the quadratic function. Completing the square. This is a general form of a quadratic function, whereas this is the vertex form of a quadratic function. Converting a quadratic expression from the general form or other form to the vertex form is called completing the square. What is completing the square? We can see that in the vertex form, the variable x is located in a bracket with square. We should also note that outside this bracket, there is no variable x. Completing the square means using the x square and x term in the quadratic expressions to construct a square, leaving no variable x outside the square. Let me repeat. When completing the square, we use the x square and x term in the quadratic expression to construct a square. But the question is, practically, how this can be done. In order to construct a square in the vertex form, we need to know the structure of the square. Let's see this example. A quadratic functions x plus 3 squared plus 5. Let's draw a square and let's make the area of this square equal to the square of this vertex form, which is x plus 3 square. Now, since the area is x plus 3 square, the dimensions of this square must be x plus 3 times x plus 3. Let's break down this square into 4 rectangles, and let's say the dimensions of the big rectangle is x times x. Since the length of the big square is x plus 3, hence the length of this rectangle must be 3, so that the sum of the length is equal to x plus 3. Of course, the width of this rectangle must also be 3. Let's move this x plus 3 square out from the square. Now let's find the area of each of these rectangles. The area of this square is x squared and the width of this rectangle is x. Hence the area of this rectangle is 3x. The area of the other rectangle is also 3x. Lastly, the area of this smaller square, which is 3 squared or 9, we can conclude that a big square with dimensions x plus 3 and x plus 3 consists of 4 rectangles with area x squared, 3x, 3x, and 3 square. To complete the square, we need to fill up these 2 squares and these 2 rectangles. The first squares need to be filled with x squared term, and the 2 rectangles need to be filled with the x terms, and lastly, the small square here need to be filled with a number without variable. Now let's see this example. Let's write this quadratic expressions x squared plus 8x in the vertex form by using completing the square. To complete the square, we need to fill up all these 4 pieces. The first piece needs to be filled with the x squared term. Therefore, the dimensions of the square is x times x. There are also 2 rectangles of same size in the square. We know that these 2 rectangles need to be filled with the x terms. Therefore, we separate the 8x into 2 terms equally, 4x each, and then fill up the 2 rectangles. Since the width of the rectangle here is x and the area is 4x, hence the length must be 4. Same for the second rectangles, the width is 4. Now we can see that the length and the width of this big square is x plus 4 times x plus 4. We're still short of one small square here to make the square complete. From the dimension of this small square where the length equal to 4 and the width is also equal to 4, the area of this last piece must be 4 times 4 or 4 square. Therefore, in order to make the square complete, we need to add a 4 square terms into these expressions and then fill this 4 square into the last piece in this big square. Now, this square is complete and the dimension of this square is x plus 4 times x plus 4. Hence, the area of this big square is x plus 4 square, which means the sum of these 4 terms is equal to x plus square. So now we successfully construct this square by using the x square and x terms in this expression. However, we are yet to complete. We have added a 4 square term into the expressions, and to make this viable, we also need to subtract a 4 square term from the expression so that the expressions remain as x squared plus 8x. Now the expressions becomes x plus 4 square minus 4 square, or x plus 4 square minus 16. Let's summarize the steps in completing the square. This is a quadratic expression. We already have the x squared term to fill up the large square. Therefore, the next step is splitting the 8x terms into 2 equally, and this is to fill up the 2 rectangles. After that, add 4 square terms so that we can fill up the small square here, and at the same time subtract 4 square terms so that the values of the expressions here remain the same. Lastly, put all the 4 terms into a bracket and then square it. And now the quadratic expression is in the vertex form. Now take note that the constant in the bracket is equal to the coefficient of the 2 x terms before we put them into the bracket. Now let's see this example. Express fx equal to x squared minus 5x plus 1 as fx plus a x minus h squared plus k. So we can see that this is in a vertex form. So therefore, we need to complete the square to convert the quadratic function from the general form to the vertex form. Let's copy this function fx equal to x squared minus 5x plus 1. And we learned that to complete the square, we need to split this 5x terms into 2 equally so that we can fill up the 2 rectangle. So we make this become 5 over 2x minus 5 over 2x. This is to split the negative 5x into 2 equal terms. Okay, and then plus 1. Okay, and the next step is to fill up the small square. Okay, we already filled up the big square. Okay, so this is a big square and a 2 rectangle. The 2 rectangle is this 2. Okay, so now we need to fill up the last square here. To fill up this last square, okay, we need to let me copy this one first. Okay, and then we need to add 5 over 2 square. Okay, to add these terms into this expression to fill up the small square here. Okay, and then we need to minus the 5 over 2 square so that the expressions remain the same, because these two, when we minus, it becomes 0. Okay, so then the values of the expressions remain the same as before. Okay, and then don't forget the plus 1 here. We still have a plus 1 here. Okay, so now we know that this 4 term is a complete square. Okay, so this one, we put them into the brackets, and then x, so the constant inside this bracket is equal to the coefficients of the x terms. So it's negative 5 over 2. Okay, and then close it and square it. Okay, and then we still have this outside the bracket. So this is 25 over 4. Okay, 5 square equals 25, 4 square equals 4, and then plus 1. And 1, we make it 4 over 4. Okay, so therefore this is equal to x minus 5 over 2 square minus 21 over 4. So this is in the vertex form. Fx equals to x minus 5 over 2 square minus 21 over 4. And in our case, our a is equals to 1, yeah, because there's no coefficients here, which means it's 1. And then our h is equals to 5 over 2. And lastly, the k is equal to negative 21 over 4. Okay, so this is how to convert a function from a general form to the vertex form by completing the square. Finding maximum or minimum point from the vertex form. We can find the coordinate of the maximum or minimum point of a quadratic function easily, directly from the vertex form. For examples, this is the vertex form of a quadratic functions. The x coordinate of the maximum or minimum point will be equal to the negative of the constant inside this bracket. So if the constant is b, then the x coordinate of the maximum or minimum point will be negative b, and the y coordinate will be equal to the constant outside of the vertex form. So for example, if the constant is c, then the y coordinate will also be c. Now let's see these two examples. So we have two quadratic functions in vertex form, and if we would like to find the coordinate of the minimum or maximum point, for the first one, the x coordinate will be the negative of the constant inside the bracket, which is negative 3. Negative 3, so the x coordinate is negative 3, and the y coordinate will be the constant outside of the bracket, which is 7. Okay, for b, okay, the constant inside the bracket is negative 5, therefore the x coordinates will be 5. If this is negative, this is positive. If this is positive, then the x coordinate will be negative. And for the y coordinate, they will be equal. If this is negative 8, then the y coordinate will be negative 8. So that's how we determine the coordinate of the maximum or minimum point from the vertex form of a quadratic function. Now let's see this example. This is a past exam questions 2003, paper 1, question 15. Given that y equal to 14x times 5 minus x, calculate the values of x when y is maximum and the maximum values of y. Okay, actually they're asking us to find the coordinate of x and y of the maximum point. Okay, so now let's rewrite these functions. Y equal to 14x and 5 minus x. So we are going to use the Vertex form to find the maximum or minimum point. And to do this, we need to expand this expression so that it becomes the general form. Okay, so let's expand it. Okay, so this is equal to 14x times 570x. 70x, and then 14x times negative x minus 14x squared, or we can rewrite it as negative 14x squared plus 70x. Okay, because in general form the x squared will put in front of the x term. Okay, in order to perform the completing the square, we need to make the coefficients of the x squared 1. Okay, what we can do is we factorize it. We factorize these expressions. We factorize it by taking out the negative 14, and then bracket x squared, and 14 times 5 equal to 70. So this is minus 5x. Okay, so to perform completing the square, we need to make sure that the coefficients of the x squared is 1, and to do this we factorize the expressions. Okay, so now we can start our process of completing the square. Okay, so the first piece is x squared, so we already have it, and then the two rectangles, we split this 5x into 2, so it becomes 5 over 2x. Okay, and then plus the last square. The last square will be the square of the coefficients of the x, which is a 5 over 2 square, and then minus 5 over 2 square. Okay, so that's it. Okay, then negative 14. Okay, now these 4 terms become a square. So is these 4 terms is x minus 5 over 2 square. Okay, and then we still have a constant here, which is minus 25 over 4. Okay, so expand it, so it become negative 14 x minus 5 over 2 square, and then plus, okay, so 87 1 over 2. Okay, so now we have written these quadratic functions in the Vertex form. Then we should be able to find the x and y value easily from this Vertex form. So question A, the values of x when y is maximum. So A, okay, at the maximum points, the x coordinate is equal to the negative of the constant inside the bracket, which is 5 over 2. Okay, and the maximum values of y, will be equal to the constant outside the bracket, which is 87 1 over 2. Okay, so that's how we find the coordinate of the maximum from the Vertex form. Okay, so now we already have the answer, x equal to 5 over 2 when the y is maximum, and the maximum values of y is 87 1 over 2. Now let us use the Casio fx-570 Classwiz calculators to verify our answer. Just now we already rewrite our quadratic functions in the form of general. Okay, this is the general form, and then from the general form we can use the calculators to verify our answer. Let's go to the menu and then choose A. Okay, this is to straight away go to the equations and function mode, And a quadratic function is a polynomial, and it's a second degree polynomial. So let's choose number 2, and then let's key in the coefficients. The coefficient for x squared is -14, and then the coefficient for x is 70 equal, the constant is 0. Okay, so because it's not showing here, so it's 0, so equal. Okay, so now it shows the roots. Okay, the roots is not important for us here. What we want to know is the maximum or minimum point. So let's use the down cursor keys to go to the maximum value of y. Okay, so from here we can see that for the maximum values of y, the x is equal to 5/2. So 5/2, that's correct. And then the maximum values of y is 175/2. Let's convert this to the mixed number. So we press Shift SD. So 87/1/2, yes, same as what we obtained in previous slide. So the Casio fx-570EX Classwiz calculator is a very, very powerful calculator. It can help us in many calculations and also help us to verify our answer